Good morning and welcome to Algebra for Wednesday, April 1st. I wish I could say this whole COVID-19 was an April Fool's Day prank, but I cannot. I'm going to start off with a review from yesterday's prompt. All right, so you had 2y equals 3x plus 8, and you had 3x plus y equals negative 5. I told you the solution was going to be negative 2, 1. But let's just see how we should have solved it correctly. What do? Well, I can see that they're not both in standard form. So this one looks good, that one does not. Again, don't just try to magically move a piece of information from one side to the other. Just use some easy math. I need to subtract 3x from both sides. And this is negative 3x plus 2y equals 8. So my first check mark was for standard form, and now they're good. After that, I have to stack them vertically. So I'm going to just bring this guy down here where it says 3x plus y equals negative 5. And now they're stacked vertically. What I didn't really notice when I was making the example for you yesterday was multiplication is not even needed for this problem because you have opposite variable pair already, in that the x's are already opposites. Let's just pretend for the time being that you didn't notice that, and I did say multiply, so you're going to multiply, and you see that that's 2y and that's plain y. Well, what's the opposite of positive 2? Negative 2. So I'm going to multiply this entire line over here by the number negative 2 to create an opposite y. Again, I know I don't have to because the x's were already opposites, but let's just presume you did it. So that's going to be negative 6x minus 2, not 6, minus 2y equals positive 10. And now that I've adjusted that line, I don't need this one anymore. I'm going to bring the other one down just to have things stacked neatly so I can see them. So now that's what I'm working with. Now that they're stacked and in standard, I'm going to add vertically. I've got everything checked off along the way. Negative 6 plus negative 3x is negative 9x. The y's will cancel. They're gone. They're done. 10 plus 8 is 18. Divide both sides by negative 9. And I got an answer of x. That's negative 2, which, again, I already told you it would be. That's good. What do I do with that information? I plug it into any of the equations to see what y will be. I'm just going to pop it over here since I have the room anyway. 3 times negative 2 plus y equals negative 5. That's negative 6. Plus y equals negative 5. I'm going to add 6 to both sides, and I get the answer of 1. My coordinate is negative 2, 1. And that is exactly what I told you the solution was going to be. So there's your homework. And let's move on now to some new examples. In these examples, multiplication will be necessary, and I just want to do a couple different things that will be good for you to see for variety. All right, so let's take this one. I got x equals negative 3y plus 67, and I have y equals 3x plus 9. Obviously, they're not both in standard. I have to put them both in standard. This one, that one, neither one's in standard. How do I put this in standard form? I have to add 3y to both sides. Because it was negative, I'm going to add. I'm going to put it in order. X plus 3y equals 67. Over here, it's in slope-intercept. Again, wrong. I want to move the x terms. They're positive 3. I have to subtract from both sides. So I will subtract minus 3x plus y equals 9. I'm not writing down every step, but I'm telling you what I'm doing. So please make sure you can follow. In the next example, perhaps I'll show you every step. Now they're both in standard. I'm going to stack them. I'm just going to pull this one over here. So that's negative 3x plus y equals 9. Okay, so that's what we're working with right now. No problems here. I do see that I don't have an opposite variable pair. It's up to you which one you want to make opposite, x's or y's. It does not matter. I see that's an x and that's a negative 3x. If I multiply this line by something, though, I'm going to have a huge number over here, and I don't know about you, I don't want to see a huge number. Okay, I'm not going to multiply this line. I'm going to choose to multiply this line and get the y's to be opposites. It makes it easier mathematically. That's a positive 3y, that's a plain old y. So what's the opposite of positive 3? Negative 3. How do I make that negative 3? By multiplying by negative 3. Distribute throughout the entire equation. Negative 3 times negative 3x is 9x minus 3y equals negative 27. Don't forget, it has to be distributed throughout the entire equation. All right, I'm done with that. I'm going to just put a line through it. I'm going to bring the other line down to stack it again. Now they're in standard, they're stacked, and there's an opposite variable pair. All I have to do now is add vertically. 9x plus another x is 10x. The y's will cancel out by design. Negative 27 plus 67 is positive 40, which means this will nicely divide by 10 to get 4. X equals 4. Fantastic. Plug it in. Right over here. Might as well. So I'm going to just take this, and it says, you know what? I'm not going to take that one. This one's easier. I'm solving for y anyway. Y equals 3 times 4 plus 9. Y equals 12 plus 9. Y equals 21. The solution to the problem is 421. Okay. So in that example, we had to do several things. We had to put them both into standard form. We had to stack them. We had to multiply to get opposite variable pairs. We had to do everything. We got the answer. Hopefully we feel confident about that example. Let's move on to the next. Okay, now in this example, we're going to have these two equations. Here we go. I'm going to go with 2x minus 4y equals 8, and y equals 1/2 x minus 4. All right, once again, we don't have standard form on both, just on the first. So put that in standard by subtracting 1/2 x from both sides. Negative 1/2 x plus y equals negative 4. So far, so good. I'm going to stack them up now, so I'm just going to drag it over here. Negative 1/2 x plus y equals negative 4. Okay. I need opposite variable pairs. I don't have one. I see that that's a negative 4y, and that's a just plain plus y. It's pretty easy to make those opposites. What's the opposite of negative 4? Positive 4. So I'm going to multiply by 4. This bottom row. 4 times negative 1/2 is negative 2x. 4 times y is 4y. 4 times negative 4 is negative 16. And now I'm done with that line. I'm going to pull that top one on down. And now they are stacked, and I'm going to add vertically. That's the plan. All right, so negative 2x plus 2x, that cancels out. 4y minus 4y, that cancels out too. It's all gone. There's nothing over here. It's still an equation. There's something over there. It's the number 0. Negative 16 plus 8 is negative 8. Now that is a problem for me because I'm pretty sure 0 does not equal negative 8. What does it mean when you get an answer where the variables are gone, but the solution doesn't really make any sense because it's a false statement? Oh, there's no solution. This is a no solution question because those lines were the same line. Just like with substitutions, just like with graphing, there is the possibility that you're going to have a special system. One in which they're the same line, or one in which they are parallel. Did I say the same line? What did I say the same line? They're parallel. All right. I think perhaps I've had enough of distance learning. Okay, they're parallel, not the same line. Oops. Parallel lines don't cross. So because they don't cross, there's no solution. Because there's no solution, we can't mathematically come up with a true statement. There we go. That's our special system. Let's move on to, obviously, the one that was on my mind in the first place, the system in which they are the same line. Hate to give away the ending like that, but here we go. So I'm going to go with x plus y equals 4 and 6x plus 6y equals 24. Well, I was nice enough to give you guys the two lines already in standard. Isn't that nice of me? I thought so. So I'm going to stack them up, and I'll put that over here. 6x plus 6y equals 24. I can see that I don't have opposites yet, but it shouldn't be too hard to create it. That's an x, that's a 6x. What's the opposite of 6x? Negative 6x. I'm going to multiply that top line by the number negative 6. I'm going to drag it on down here too. Negative 6 times x is negative 6x. Negative 6 times y is negative 6y. Negative 6 times 4 is negative 24. I'm going to add them up because I have them in standard and stacked and opposites. 6x, negative 6x cancels. 6y, negative 6y also cancels. Once again, we have no more variables to work with. It is still an equation, so there is still something on that side. It is the number 0. What's on the other side? 24 plus negative 24. Hey, wait, that's also 0. Well, once again, we have a special system. The variables have canceled out, but so have the constants. We're left with a true statement, which tells us that in this case, we have the same line, which is what I was thinking of earlier, which means there are infinite solutions. Infinite solutions. That's our second kind of special system. All right. So one final problem to do. This one's not going to be special, except it's going to have a little bit more multiplying to do. Because, of course, why wouldn't we want to do more work? So we have 3x plus 2y equals 6. I'm going to stack this one for you in the first place. 2x minus 3y equals 4. All right. They're both in standard. They are stacked, so that is a little bit of a help. I need to make opposite variable pairs, and I have a 3x and a 2x and a 2y and a negative 3y. This time, it's not as easy to make an opposite variable pair. It's not hard. It just means we have to multiply both lines by some numbers that will create opposites. I have a 3 and a 2. What's the least common multiple of 3 and 2? 6. So I want them both to be 6s, although one's positive and one has to be negative, otherwise we won't eliminate anything. So I'm going to multiply this line by 2, but this one's going to be a negative 3. Otherwise I can't eliminate anything. I won't get a positive and a negative. Distributing throughout, I get 6x plus 4y equals 12. That's the first equation. And then I got negative 6x plus 9y equals negative 12. Okay, they're stacked. I have opposite x's. I can add. What happens when you add the x's? They go away. 4y plus 9y is 13y. 12 plus negative 12 is 0. There's nothing wrong with that. The number 0 is a good number. Don't worry about it. We can still solve this. I have to divide by 13. But what's 0 divided by 13? Well, it's 0 again. So the y value of the answer is going to be 0. All right, good. Plug it in. So I'm going to take the first equation. It doesn't matter which one. All four, this one, that one, or the translated ones are fine. I'm just going to choose the top one. So 3x plus 2 times 0 equals 6. 3x, 2 times 0 is nothing, equals 6. Divide by 3, I have the answer 2. So the solution is 2, 0. That's where these two lines are going across. It had a little bit more work to it, but in the end, it wasn't all that difficult. Yes, it will take practice. I know. So here's what I want to do. So far as your assignment goes, there's no actual technical homework to hand in today, but there is an IXL assignment that I want you to start. It's going to be due Friday by 3 o'clock. It is one strand of IXL. I'm not going to add to it. So I'm going to write it down over here for you so that you do not forget. Please go to IXL. It is the Algebra 1 strand, of course. The task is U.10. And I want you to get to 90% or better. And yes, you could earn extra credit if you do better. That is the assignment due by Friday, all right? So due Friday by 3 p.m., please. I will say that if you're interested in any extra credit, and some of you might be, the U.12 task will be extra credit if you can get to 75% or better, all right? I'll figure out how to work that into the extra credit, but that's going to be double or extra, maybe a double homework, whatever it is, more credit for you, for U.12. But this is the assignment I'm looking for Friday. Other than that, I'm still working on your quizzes, and everything else will be done in due time. I hope you've been having a good week, and I will talk to you tomorrow. Thank you.